Nhasi tiri kuita physics. Toda kuita topic inonzi physical quantities and units. Saka tichatanga nekutarisa ma-physical quantities. Tiri pama-physical quantities, we need to understand what is the definition of a physical quantity. Saka a physical quantity is a quantity which can be measured using an instrument. Saka kana tiine quantity yatinokwanisa kumeasure tichishandisa an instrument, that quantity inonzi a physical quantity. Let us give examples. Tine length. Length is a physical quantity because it can be measured using a ruler or a tape measure. Then our next example, we have time. Time is also a physical quantity because we can measure time using either a stopwatch or a clock. Saka aya ma-examples ema-physical quantities atinawo, length and time, but tichadiscussa more examples of physical quantities. Tiri pama-physical quantity. A physical quantity has both magnitude, which is also called size, and units. Saka takatarisa a physical quantity. A physical quantity is made up of two things. Chekutanga, it is made up of magnitude. Kana chiti magnitude tenge chireva size. Then secondly, it is also made up of units. So we have an example here. A mass of 20 kgs. Saka tine a mass of 20 kgs. Kana tichiti magnitude, kana kuti size, tinenge tichiti the magnitude is numerically represented. Kana chiti numerically represented, tinenge tichiti it is shown as a number. Saka tikatora example yataisa panapa ye a mass of 20 kg. The number 20 ndiyo ichatiudza about the magnitude. Then kg of course iri kutiudza about the units. Saka ma-units akakosha kuphysics. Ku-mathematics, that is O level maths, unogona tosiya ma-units, and in most cases kana kuri kupaper 1 vanenge vakatokupa ma-units acho. Asi in physics, units are very very important. Ukasiya ma-units, chances are very high that you are going to be marked wrong. Saka take note that you should always include the units. There are two types of physical quantities. Tine anonzi ma-base physical quantities. Then we have anonzi ma-derived physical quantities. So for physical quantities, tine the base physical quantities. Then we have what are called derived physical quantities. Base physical quantities are obtained from direct measurement. Let us take an example. Ngatidzokere kwatabva. Tapa ma-examples panapa patakachidiscuss about physical quantities. Kuti a physical quantity is a quantity which can be measured using an instrument. Then we gave an example of length and also an example of time. Saka tikatora length for instance. Tikaenda kumberi kunoku, tadzidza kuti a base physical quantity can be obtained using direct measurement. Kana iri length, let us say tine muti panapa. Tikada kumeasure the length of this tree. Tokunotora tape measure handi. Imwe part ye tape measure yoiswa panapa, then imwe part iyoyo yoiswa panapa. Saka this is basically the length of the tree, maybe in meters. So we can directly measure length tichishandisa an instrument, be it a ruler or not a tape measure. Because of that, length is a base physical quantity. Ndosaka pama examples pedu panapa. Tapa length, tapa futi mass. We can directly measure mass tichishandisa a balance. Then time, of course, using a stopwatch. Temperature, kune vakamboenda clinic, using a thermometer. Saka this is what a base physical quantity is. What about a derived physical quantity? A derived physical quantity can be obtained from the manipulation of base quantities in formulas. Saka kuti uzive kuti iyi i base physical quantity, kana kuti iyi i-derived physical quantity. For a derived physical quantity, kuti uiwane that quantity, you need a formula. And because tikushandisa a formula, zvikureva kuti we cannot measure it directly. Examples of derived physical quantities. Saka toda kupa a recall maybe from what we just learned. Kuti kana chitaura pamusoro pe a derived physical quantity, tiri kuti in order for us to obtain it, we need to have a formula. We need to manipulate certain variables using a formula. So tiri panapa, force is an example of a derived physical quantity. Force is derived from the formula force is equal to mass times acceleration. So this formula, F for force is equal to ma, mass times acceleration, is actually the second Newton law of motion. Saka ma Newton laws of motion tichazoma discuss later. This is just a precursor. Our second example of derived physical quantities is pressure. Saka we can derive pressure from the formula. Pressure is equal to force over area. So pressure is equal to force over area. Note, the pressure in fluids is calculated using this formula. P for force is equal to rho gh. Rho iri kumirira density, g iri kumirira acceleration of free fall, h iri kumirira height above the point where the pressure is exerted. So I don't have to stress equals over my formulas higher because we are going to dive in more deeper patichaita topics higher. Saka chatinoda kudzidza panapa ndechekuti a derived physical quantity, kuti tiiwane, we need to manipulate a formula, whereas a base physical quantity, kuti tiiwane, we just need to measure directly. Tapa topic yema units. For my units edu, we have SI units. But before we go any further, my units vakare are categorized mainly in three ways. Tine anonzi ma SI units, tine anonzi ma derived units, then tine anongonzi other units. Saka our first point iri kuti the units of physical quantities can either be SI units or derived units. Saka ma SI units ma derived units ndo akanyanya kukosha. Ndosaka tama highlighter panapa. Asi tine amwe ma other units. We are going to discuss kuti chii chinombonzi ma other units. Our second point, the SI unit is the international system of units of measurement. The international system. So why do we have an international system of units? This takes us to point number 3. Scientists adopted SI units for easier communication across different languages and cultures. So I know my examples are now ema SI units. For example, the SI unit of mass is kilogram. And I want you to take particular note panap. With the SI unit of mass is kg, not grams. Then our second example, the SI unit of time is seconds. And then lastly, the SI unit of temperature is Kelvin. Panapa vanhu vakawanda vanoita kuti mistake, vanofunga kuti SI unit ye temperature is degrees Celsius. No, the SI unit of temperature is called the Kelvin. We need to clarify this point. Iri kuti scientists adopted SI units for easier communication across different languages and cultures. What do we mean? Example yatinayo panapa. We have 4 scientists. Ma scientists aya SR4 chataura mazita avo. Basa ravo riri mostly based on what is called yaningati the quantum theory. Kana kuti more broadly theoretical physics. Theoretical physics. Saka ma physicists ese atinawa. Saka ma scientists aya, they come from different countries. Vekutanga vari panapa vanonzi Temba Dlodlo. forgive me kana ndisina kutaura senemi yavo zvakanaka. Ava muZimbabwean vanobva from Zimbabwe, kureva kuti the continent of course is Africa. Then this lady, it's Sabine Hosenfelder. Sabine Hosenfelder, she is from Germany. Then this gentleman, it's Michio Kaku. Michio Kaku is from Asia. Then this man again, it's Tyson Neil deGrasse. Tyson is from the Americas. Saka we have a scientist from Africa, from Germany, from Asia, from America. Ma-scientists esaya, they are practicing kana kuti vakadzidza the same field of physics, not theoretical physics. In order for them to be able to communicate efficiently, they need to agree on the units. Havanoita ma-calculations avo kuti kana Dr. Dlodlo vakaita calculation vakaitumira kuGermany ikatanga kureviewa a peer review by Dr. Sabine, vanofanira kugona kucommunicata zvakanaka. Saka for example, let us say kuti varoda kumeasure length. Andika vese vachashandisa the meter, because a meter, though the SI unit kana the standard international unit of length, kunyange vekuAmerica vamheno kuti I think it's politically motivated, vane different system of measurement yavanoshandisa, but generally speaking, kana tichitaura pamusoro pelength, ma-scientists ese aya coming from different cultures and languages vachashandisa the meter. If we are talking about, for example, time, which is something they really calculate a lot, vese vachashandisa chi? The second. Derived units. Derived units are derived from the formulas of derived physical quantities. Saka tina anonzi ma-derived units. Remember, summary yataipa yaiya kuti we have units, tine ma-SI units, tine ma-derived units, then lastly, tina tinongoti ma-other units. Saka for derived units manje, these are derived from the formulas of derived physical quantities. What do we mean? Remember the Newton, and it's a unit of what? Of force. Saka tine force panapa ndiri. Then 1 Newton, it's equal to 1 kg meters per second squared. 1 Newton is equal to 1 kg meters per second squared. This is derived from the formula F is equal to ma. This formula F is equal to ma, if you remember, we will the second Newton law of motion. So formula ish ndiyo iri kutipa chi this derivative, and this derivation of what 1 Newton is. Because tangoti force is equal to mass times acceleration, anditi. So vatangoisa chi the SI unit of mass, which is kg, I multiply net the unit of acceleration, which is meters per second squared. So vatawana chi kg is meters per second squared. Our second example is the Pascal. Saka Pascal e tinenge chidila ne the derived physical unit inonzi pressure. 1 Pascal is equal to 1 Newton per meter squared. Why? Because the Pascal is derived from the formula P for pressure is equal to force over area. Saka P is equal to force over area. Then we know that the unit of force in Newton and the unit of area in Ngerichi meter squared. That's why that Newton per meter squared. Then I will discuss some other units. There are other units which are used in everyday life. We can give an example of mass. The other units of mass are kuna anonzi magallons. Aya magallons aya muchishona ndo anozonzi magarani. Kune vakamboenda kuchigayo munoziva kuti kune garani. Garani, it's a transliteration of the word gallon. So we have gallons, we have pounds, we have stones. These are other units of mass. Saka tichazoona other units of different physical quantities in just a moment. Takuda kudiscussa the base physical quantities and SI units. Saka, SI units ndo ma-units ema-base physical quantities. Tati base physical quantity chi. Tati base physical quantity quantity inowanikwa through what? Direct measurement. Handiti. Tikapa example ye-mass length time temperature. Panapa tazowedzera current, light intensity ne-amount of substance. So table yatiinayo kuno iri kuti iyo base quantities handiti. We have mass, we have length, we have time, temperature, current, light intensity, amount of substance. Then the SI units for mass kilogram, kg. The other units of mass, vamwe vanoshandisa ma-pounds. Takura chona wrestling, it's John Cena, 250 pounds, yeah. You understand? Saka in America they use pounds. Vamwe vashandisa ma-stones, then kusvikayo kwedu toshandisa magarani kana kuti migomo. Let us go over to length as a base quantity. The SI unit of length is the meter. The other units, vanoshandisa foot, vanoshandisa inches. Kwa America kunowanzoshandiswa ma-miles. These are the other units of length. Then time, the SI units of time, seconds, other units, hours, minutes, what have you. Then temperature, SI units, the Kelvin, other units, degrees Celsius. Degrees Celsius. Kunyangwe tikaenda kukliniki kazhinji temperature yedu aimeasure in Kelvin. Measurement yavanotudza degrees Celsius. But because of some complications, vakaona kuti Kelvin iri more efficiently used than the degrees Celsius. Then for current iri under the topic of electricity, we are going to do it. The SI unit is the ampere. Light intensity, the SI unit inonzi candela. Amount of substance, kunoku zvichazwana kuchemistry. The SI unit inonzi iyo the mole. Saka chakanyanyokosha this slide kuziva ma-SI units and anowanzoconfuse vanhu nepa-temperature. Saka chenjerai, pamass nepa-temperature vanhu vanowanzoconfuse. Vanhu vanowanzoconfuse vachiti the SI unit of temperature degree Celsius, iyo iri Kelvin. Vanhu vanoconfuse vachiti the SI unit of mass grams, actually iyo iri the kg. Derived quantities and derived units. Saka for derived units are the units for derived physical quantities. And remember kuti kana chiti derived physical quantities, we are actually, or basically, we are deriving from formulas. Kangoisa ma-formula, takutodhila nema-derived quantities, nema-derived units zvakare. Saka table yedu manje yava a bit more elaborate. Tine ma-derived quantities, tine ma-formulas acho, tine ma-derived units, then panapa tasammarize derivation yacho. So regai tichizviita in more detail. Please can you forgive me panapa ndaita mistake. Aya ma-SI units ema-derived quantities, aya ndo ma-derived units. Saka this is the derived unit and this and this. Kuti Newton, kuti Joule, kuti Pascal, they are actually standard international units. The SI unit of force in Newton, as the derived unit of force is 1 kg meters per second squared. The SI unit of work cannot energy is Joule, as the derived unit is 1 Newton meter. The SI unit of pressure is Pascal, as the derived unit is Newton per meter squared. The SI unit of density, which is also the derived unit in this case, is kgs per cubic meter. So here it was a mistake actually. How are we going to derive? Derivation actually it was say. Saka for force, we know that the SI unit in Newton. So 1 Newton is going to be equal to, what is the SI unit of mass, kg? So it's 1 kg multiplying What about acceleration? Units acceleration tishandisa standard international units, it's meters per second squared. That is why 1 Newton is equal to 1 kg meter per second squared. Saka ndo zvangoitika futi work panapa. We know that work kana kuti energy, work energy, they are basically the same thing. We calculate it, formula yedu inoti yo force times distance. Force times distance. Saka panapa manje takuti isusu, what is the force? The Newton, and multiplying the distance, which is in meters. That's why answer yedu yangova 1 Newton meter. The same zaitika pa pressure. Formula ya pressure inoti yo force over area. Formula ya pressure at force over area. What is force? A Newton area meter squared. That's why it is 1 Newton per meter squared. Then density, it's mass over volume. Saka kana iri mass over volume for density, mass over volume. Mass inenge iri kg over volume iri meter cubed. That's why yazoita kg per meter cubed. So that is how we derive. Maderiviro atinoita. Saka aya to reiterate nekucorrecta mistake yangu. Aya ndo derived units. Aya derived units. Aya ndo derived units. Asi kuti Newton, kuti Joule nekuti Pascal haazi derived units, ndiwo SI units derived quantities. I hope you do not find this confusing. Thank you for attending to this lesson.